Hi, hello dear students, welcome to my channel Maths with Panindra. In this video, we are going to discuss quadratic equations and expressions. Some synopsis like a brief introduction and some examples based on the different concepts we are going to discuss in this session. So first of all, what is the quadratic expression? What is meant by quadratic expression? If a is not equal to 0, b comma c are real or complex numbers, then ax square plus bx plus c is called quadratic expression in x. Quadratic expression in x. So this is called quadratic expression. So in that, compulsory a should not be equal to 0 and b comma c real or complex numbers. For example, x square minus 7x plus 12. This is a quadratic expression. X square plus 8x plus 12. This is also another quadratic expression. Sir, why sir you are writing only in algebra? Why can't write in the complex number form? We can. X square minus 5 plus 2i plus 25. Just roughly I am writing. X square minus 5 into 5 minus of 5 plus 2i plus 25. So this is a quadratic expression. Whatever the term is of the form ax square plus bx plus c is called quadratic expression. Now come to the root or 0 of the quadratic expression. A complex number alpha is said to be zero of the or root 0 of quadratic expression. Ax square plus bx plus c. If whatever the term we are making as 0 of the quadratic expression, in place of x that value you can substitute. Here alpha is the 0, no? So if a alpha square plus b alpha plus c is equal to 0, then only alpha is 0 of the quadratic expression ax square plus bx plus c. Suppose for example, two is a 0 of x square minus 4x plus 4. Absolutely x square. So x is equal to 2, substitute there. So 4 minus 8 plus 4 plus 4 plus 4, 8 minus 8, 0. So whenever you are getting the value x square minus 4x plus 4 value equal to be 0. So that is then the value alpha is called 0 of the quadratic expression. Similarly, quadratic equation Same definition but a little change. If a is not equal to 0, b comma c are real or complex numbers, then ax square plus bx plus c equal to 0 is called quadratic equation. Next, same definition, quadratic equation. If a is not equal to 0, b comma c are real or complex number. Then ax square plus bx plus c is equal to 0 is called a quadratic equation. In x, suppose in terms of y is the quadratic equation in terms of y, we can say that sorry, for example, x square plus 2x plus 1 equal to 0, x square minus 3x plus 2 equal to 0. It's a quadratic equation. So different quadratic equations we have. So after defining the quadratic equation, we have another important concept, a root of a quadratic equation. A root of a quadratic equation. So how to define the root of the quadratic equation? If we already discussed that 0 alpha, if a alpha square plus b alpha plus c is equal to 0, then alpha is called a root or solution of a quadratic equation. Of ax square plus bx plus c equal to 0. So how to define the roots? The roots of the quadratic equation. The roots of quadratic equation, simply I am writing ax square plus bx plus c equal to 0, or x equal to minus b plus or minus root over b square minus 4ac divided by 2a. And delta is equal to b square minus 4ac is called its discriminant. Just I am revising that we already discussed in that IP classes. Just for that in EAMCET JEE Mains also, just I am giving the synopsis briefly. Here x is equal to minus b plus or minus I have given, no? Let us consider one root is alpha, another root is beta. So one is minus b plus root over b square minus 4ac divided by 2a. Another one is minus b minus root over b square minus 4ac divided by 2a. Here whenever alpha, beta are the roots of the quadratic equation, alpha comma beta are roots of quadratic equation ax square plus bx plus c equal to 0, then sum of the roots and product of the roots. Alpha plus beta is equal to, whenever we are adding these two, minus b by 2a minus b by 2a, the rest of the terms will be going to get cancelled. So minus b by 2a minus b by 2a minus 2b by 2a. So 2 to get cancelled, minus b by a. That also can be written as minus coefficient of x divided by coefficient of x squared. Similarly, product of the roots, if you do the product of these two, alpha into beta, whatever I kept in the boxes, multiply a plus b into a minus b, a square minus b square, and then simplify, you will get at last c by a. So c by a, that can be defined as, c means what? Constant term, constant term divided by coefficient of x square. This is about alpha into beta, product of the roots and the sum of the roots. Not only these two, sometimes they will ask the difference of the roots, alpha minus beta or beta minus alpha. So alpha minus beta can be written as, from the algebraic formulae, root over alpha plus beta minus 4 alpha beta. So in this alpha plus beta and alpha beta, if you substitute and simplify, you will get a root over b square minus 4ac divided by mod a. This is the difference of roots. Difference of roots, mod alpha minus beta equal to root over b square minus 4ac by mod a. Sometimes they will ask sum of the squares of the roots, alpha square plus beta square. Even here also, a square plus b square means a plus b whole square minus 2ab. Like this we can write it. So if you simplify alpha plus beta and alpha beta values, substitute in that simplify, you will get b square minus 2ac divided by a square. So these are the formulae we will use in the problems. If they will ask to calculate alpha square plus beta square, whenever one quadratic equation is given, directly you can apply b square minus 2ac by a square. And one more important thing, alpha cube plus beta cube. Alpha cube plus beta cube. So generally a plus b whole cube means a cube plus b cube plus 3ab into a plus b. So from that, a cube plus b cube make as a subject, like alpha cube plus beta cube. So you will get alpha plus beta whole cube minus 3 alpha beta into alpha plus beta. So substitute the values of alpha plus beta and alpha beta and then simplify. You will get alpha cube plus beta cube as 3abc minus b cube divided by a cube. So these are the formulas you have to remember. Point by point. These are the 5 important points: alpha plus beta, alpha beta, mod alpha minus beta, alpha square plus beta square, alpha cube plus beta cube. After that, one important, we can express like this: if alpha and beta are the roots of ax square plus bx plus c equal to 0, then the quadratic expression can be taken as otherwise ax square plus bx plus c is equal to a into x square coefficient, whatever it is there, that we can write it. After that, alpha and beta are the roots, no? So x minus alpha into x minus beta. This is one of the possibility to write the quadratic expression ax square plus bx plus c as a into x minus alpha into x minus beta. And one more, if alpha beta are the roots of the quadratic equation, we can write like this also. The quadratic equation whose roots are alpha comma beta is given by x square minus x into alpha plus beta plus alpha beta is equal to 0. So this is the equation of quadratic equation whose roots are alpha and beta. You remember that quadratic equation cannot have more than two roots. Why? Because quadratic means only two roots we have. It cannot have more than two roots. So we can write it as, that is, x square plus x into alpha plus beta minus of alpha plus beta, no? So here x alpha plus beta, sum of the roots plus alpha into beta, product of the roots. This is the way we can write it. X square minus x into sum of the roots plus product of the roots equal to 0. Suppose, for example, 7 plus or minus 4i are the roots of the quadratic equation. Find the quadratic equation means alpha equal to 7 plus 4i, beta equal to 7 minus 4i, and substitute in this, and we can simplify, you will get the answer. And one objective question we will discuss: whenever it is a root, if alpha comma beta are the roots of ax square plus bx plus c equal to 0 and c is not equal to 0, then the value of 1 by a alpha plus b whole square plus 1 by a beta plus b whole square is equal to options b square plus 2ac divided by a square, b option b square minus 2ac divided by a square, c square, c c square minus 2ab divided by a square b square. So c square plus 2ab divided by a square b square. So how to deal this type of problems? Listen carefully. Whenever alpha, beta are the roots of the quadratic equation, we can write like this now. Alpha is a root, then a alpha square plus b alpha plus c equal to 0. So a alpha square plus b alpha is equal to minus c. So alpha, take the common. So a alpha plus b is equal to minus c. So I want a alpha plus b is equal to minus c by alpha. Take the reciprocal here. 1 by a alpha plus b is equal to minus alpha by c. But 1 by a alpha plus b whole square means squaring on both sides. So 1 by a alpha plus b whole square is equal to alpha square by c square. Similarly, beta is a root. Beta is a root. Then directly I am writing wherever alpha is there in this, 1 by a beta plus b whole square is equal to beta square by c square. So just you have to add these two only, no? So therefore, come to the question. 1 by a alpha plus b whole square plus 1 by a beta plus b whole square is equal to alpha square by c square plus beta square by c square. It is equal to 1 by c square into alpha square plus beta square. Just now we discussed alpha square plus beta square value. So once again you recollect, 1 by c square into alpha square plus beta square value is b square minus 2ac divided by a square. Suppose if you do not remember what you have to do, just I will give it, after that I will rub it. Alpha plus beta whole square minus 2 alpha beta, in place of alpha plus beta minus a by b, alpha beta value is c by a. Substitute and simplify, you will get that b square minus 2ac by a square. I hope everyone understand. So for understanding purpose of writing, so b square minus 2ac divided by c square a square, which is the required one. So b square minus 2ac by c square a square, it is there in the second option. This is the way the questions they are asking in the competitive exams. And here, very important concepts, properties of roots. So these are the important, based on properties of roots we have the questions. Roots of the quadratic equation. So first point, in the roots the discriminant is going to play the major role or important role. The quadratic equation is ax square plus bx plus c equal to 0, and where a is not equal to 0, obviously b comma c which are belongs to real or complex numbers, and delta is always greater than 0 if you take it. Here points, if you observe that, if the coefficient of x square and constant, if a and c are of the same sign, then C by A, that means product of the roots, then C by A is also positive, and hence the roots have same sign. Roots have same sign. Same procedure if A and C are opposite signs. Second property, same sign is there means same sign. Roots also. If A and C are of the opposite sign, opposite sign is not correct, opposite signs, then C by A is negative. Why? Because opposite sign means one is plus, another one is minus. Obviously is a negative, and hence concludes that, and hence the roots have different sign or opposite sign. This is, so observe carefully in the quadratic equation. By observing the values of A and C, we can conclude that A and C are having same sign, then C by A is also positive, then having the roots having the same sign. Roots are different signs, A and C also opposite signs, one is plus, another one is minus. This is first property. In that first property, both you can conclude in one, but according to convenience we are writing as a second. Two important points. Suppose coefficient of x square and constants are equal. Coefficient of x square in the quadratic equation is what? A. If A is equal to C means constant, coefficient of x square and constants are equal, then the roots are reciprocal to each other. Then the roots are reciprocal to each other. That means, suppose 2 is a root of the quadratic equation. If A is equal to C in that equation, 1 by 2 is also a root of this equation. That is the meaning. If A is equal to C, then the roots are reciprocals to each other. And the coming property is very, very, very important. Based on this, I will discuss the questions also. If A plus B plus C is equal to 0, that means coefficient of x square, coefficient of x and constant. If sum of coefficient of x square, coefficient of x and constant is equal to 0, then the roots are 1 and C by A, product of the roots is there now. So whenever you identify in the given quadratic equation A plus B plus C is equal to 0, we decide that 1 is one of the roots and C by A is also another root. Similarly, if it is A plus C is equal to B, that means A and C are positive sign and B is negative sign. If A plus C is equal to B, that means B we can take this as minus only now. So if A plus C is equal to B, then the roots are, whenever a plus b plus c is equal to 0, roots are 1 comma c by a. Whenever a plus c is equal to b, the roots are -1 and minus c by a. That means both are negative, -1 and minus c by a. We will discuss problems based on this one and this one also. Whatever I am putting here some star marks, we will do that. See here, examples we will find out. In the common roots concepts also we will apply based on these properties of roots. So one by one we will discuss. Before example, what we can do is, if the roots are in the ratio, if the roots are in the ratio m is to n, then m plus n whole square into AC is equal to mn into b square. So whenever this condition satisfies, or we can write like this also, m plus n whole square by mn is equal to b square by AC. So the roots are in the ratio m is to n. Suppose in the question the roots are in the ratio 1 is to 2, then find the condition. That time you can apply m plus n whole square by mn is equal to b square by AC. For this we will consider example. If one root of the equation, ax square plus bx plus c equal to 0 is double the other, then the relation between a comma b comma c is, first option 9ab is equal to c square, second option 9ac equal to 3b square, third option 9ac is equal to 2b square. Fourth option 2ac is equal to 9b square. Here the given quadratic equation is ax square plus bx plus c. The roots are in the ratio, one root is double the other root. So alpha is to beta. One root is double its root means 1 is to 2. So that means m is to n, that is equal to 1 is to 2. Just now I discussed that formula, m plus n whole square by mn equal to b square by ac. So we have the condition m plus n whole square by mn is equal to b square by ac. So m value 1, n value 2, substitute. So 1 plus 2 whole square by 1 into 2 is equal to b square by ac. So that implies 1 plus 2, 3. 3 square is 9. 9 into ac. 9 ac is equal to b square into 2. 2b square. So the condition for the one root is double its other root. Double for the other root. Then the relation between them is 9ac is equal to 2b square. So which is there in the third option. Double the other root. So by using this formula, m plus n whole square by mn is equal to b square by ac. This is the way you can utilize the property. And one more property we will. Nowadays they are asking in the JEE mains also this type of questions. Regularly we observe that. If p into q minus r into x square plus q into r minus p into x plus r into p minus q is equal to 0, and condition applied as where p is not equal to q is not equal to r, has equal roots, the value of 2 by q in terms of p and r is first option p minus q by pr is equal to 2 by q. B option p plus r by pr is equal to q by 2. P plus r by pq is equal to 2 by r. Fourth option p plus r divided by pr is equal to 2 by q. These are the options available. Observe that carefully the quadratic equation which it is given. The sum of coefficient of x square, x and constant. So here p into q minus r plus q into r minus p plus r into p minus q is equal to 0. Obviously it is 0. By actual multiplication, all the terms are going to be 0. So that time, whenever sum of the coefficient of x square, x and constant equal to 0, that implies that 1 comma c by a are the roots. So what is c by a in this? That implies that 1 comma c by a. C by a from the equation is r into p minus q divided by p into q minus r. These are the roots. 1 comma c by a are the roots. The quadratic equation, if we compare with ax square plus bx plus c, so c value, a value we wrote it here. And one more condition is there, has equal roots. Given quadratic equation, given that equal roots. So equal roots means one root is 1, another root is r into p minus q divided by p into q minus r. So both roots are equal. So cross multiply and simplifying, p into q minus r is equal to r into p minus q. So that implies pq minus pr is equal to pr minus rq. So minus rq we are taking into this side. pq plus rq is equal to pr plus pr. So take common q from here. Q into p plus r is equal to 2pr. They are asking to find the relation, no? So what I am doing is p plus r by pr is equal to 2 by q. Now we will check that options, which option is going to satisfy. So p plus q is there in the numerator. How many options are there? 3 options are there. By denominator, pr it is there in the b and d options only. So either b or d are the right options. In the RHS, 2 by q is there, 2 by q. So d option is the right option. Here only one thing. First observe that sum of the coefficient of x square, x and constant terms equal to 0 means the roots will become 1 and c by a. So 1 and c by a, 1 is alpha and c by a value is beta. Since the given quadratic equation has equal roots, whenever equal roots means 1 is equal to this one. So by simplifying you will get this condition. I hope everyone understand, dear students. Yeah, one more question we will discuss based on the properties. The roots of ax square plus 2bx plus c equal to 0 if a comma b comma c are in arithmetic progression, or so options 1 comma c by a, minus 1 comma minus c by a, 1 comma b by a, 1 comma minus b minus b by a. These are the options. So how to do that? We can use that property, whatever we discuss the properties. So what is the given quadratic equation? Ax square plus 2bx plus c equal to 0. And condition a comma b comma c are in arithmetic progression. Whenever a, b, c are in arithmetic progression, twice of the middle is equal to sum of the extremities. 2b is equal to a plus c. Somewhere we observe that 2b is equal to a plus c. See, just I will show that properties. Yeah, here A plus C is equal to B. A plus C is equal to B. But in place of minus 1 and minus C by A are the roots. This property we are going to utilize here. A plus C is equal to B. Sir, here you said A plus C is equal to 2B. But in here the quadratic equation is AX square plus BX plus C. No? Here the quadratic equation is in place of B, 2B is there. So 2B equal to A plus C, then the roots are negatives of the roots, that is minus 1 comma minus C by A, so which is there directly. So second option is the right option. That is the use of properties. If you learn thoroughly the properties, you are able to give the answer. Hope everyone understand. And one more problem based on that. Before that, the nature of the roots also we will discuss. Nature of the roots. Roots of the quadratic equation. The quadratic equation is ax square plus bx plus c equal to 0, and where a is not equal to 0, b is equal to b comma c are real numbers. So first property, anyway a is not equal to 0, b comma c are real, and discriminant, nature of the roots is based on discriminant of the quadratic equation. Discriminant of the quadratic equation is greater than 0, then the roots, you know that, once again I am repeating, then the roots are real and distinct. If delta is equal to 0, then the roots are equal. And real. Real and equal, that is good. So the third one, delta is less than 0, then the roots are non-real, means imaginary or complex numbers like conjugate each other. Non-real, that means it is conjugate complex numbers. Like a plus or minus ib, just simply I am saying p plus or minus iq. This is about the nature of the roots. When delta is greater than 0, then the roots are real and distinct. Equal to 0, real and equal. Delta is less than 0, then the roots are non-real. That means conjugate complex numbers, which are like a plus or minus ib, p plus or minus iq. Even the roots which are based on rational also we can consider. This is one type of category. In the second category, if a is not equal to 0, comma b comma c are rational, previously real we have taken, no? Now it is rational, and again first property, delta is greater than 0, and is a perfect square, and delta is a perfect square. then the roots are rational and distinct. Then the roots are rational and distinct. Suppose if it is delta equal to greater than 0 is over. Greater than 0, one more. Here greater than 0, two cases are there. One is perfect square, one is not perfect square. Delta greater than 0 and delta is not perfect square. Then the roots are conjugate surds. Roots are not rational, conjugate surds. Conjugate surds. Surds means like a plus root b, a minus root b. Like this forms it will come. A plus or minus root b. This is the form. These are the forms. Anyway, b is not equal to 0. Why? Because it is in the root, even non-negative. So alpha plus or minus, sorry, a plus or minus root b, or alpha plus or minus root b, p plus or minus root q. Like this way we can. In this third one, delta equal to 0. Clearly delta equal to 0 means wherever it is equal roots and rational here, not real. Then the roots are equal and rational. The last one here is the fourth property. If delta is less than 0, then the roots are non-real conjugate numbers. Then the roots are non-real conjugate complex numbers. That is like a plus or minus ib or p plus or minus iq. This is the way. These are already we discussed in the IP classes in intermediate. Just I am revising for briefly. But how many times if it is repeated also is a little like confusion, but still you have to practice. So based on this one question, based on the roots, if a comma b comma c are real, then the roots of the equation a square plus b square into x square minus 2b into a plus c into x plus b square plus c square is equal to 0. Or real and equal. Then the progression in which A, B, C lies in First option AP, second option GP, third option HP, fourth option arithmetic geometric progression AGP. So here, what is the given quadratic equation? First you write it. Actual multiplication also do it. A square plus B square into X square. That means A square X square plus B square X square minus 2B into A plus C into X. So minus 2ABX minus 2BCX plus B square plus C square is equal to 0. So here, if you observe carefully, I'll make a mark. A square X square minus 2ABX plus B square and B square X square minus 2BCX plus C square. So here we will make a perfect square. So A square X square minus 2ABX plus B square is the expansion of AX minus B whole square plus B square X square minus 2BCX plus C square is the expansion of BX minus C whole square is equal to 0. The sum of the squares is equal to 0 means A square plus B square equal to 0 means either A equal to 0 or B equal to 0 or A equal to 0, B equal to 0, both. So it implies that AX minus B equal to 0, comma BX minus C equal to 0. Just now I told now A square plus B square equal to 0. Sum of the squares of the numbers equal to 0. So each number should be equal to 0. So AX minus B equal to 0 means AX is equal to B. So X is equal to B by A. Similarly, Bx minus C equal to 0 means Bx is equal to C. X is equal to C by B. So both the X values are equal, no? Both X values are equal means we will equate these two. So B by A is equal to C by B. Cross multiply. B into B. B square is equal to AC. Whenever B square equal to AC means that implies that A comma B comma C are in geometrical progression or in GP. So A, B, C are lies in the geometrical progression. I hope everyone understand. This is the way the questions are going to ask. So based on that equal roots means what? Delta should be equal to 0. The next question, the nature of the roots of x square plus x minus 1 equal to 0 is so options is there, but just now we discussed about the nature. We will decide directly how it will be by finding delta value, ABC values. We will conclude. What is the given quadratic equation? X square plus x minus 1 equal to 0. A is equal to 1, B is equal to 1, C is equal to minus 1. Compare with ax square plus bx plus c. Then find delta value b square minus 4ac. So b square 1 square minus 4 into 1 into minus 1. So which is equal to 1 plus 4, which is equal to 5. So delta equal to 5, it is not a perfect square. Is not perfect square. Whenever it is not perfect square, roots are irrational. It means here, whenever delta is not perfect square, here it is, then the roots are conjugate surds, irrational conjugate surds. So therefore, conclusion, the roots are irrational. Irrational means like a plus or minus root b, irrational, and conjugate surds, So this is the way you have to give the conclusion. Another question also we will look into that. The nature of the roots. The nature of the roots of 2x square plus x plus 6 equal to 0 is. So here also we will discuss how to. The first given quadratic equation, you have to write it 2x square plus x plus 6 equal to 0, and a is equal to 2, b is equal to 1, and c is equal to 6, and calculate the value of delta b square minus 4ac. So 1 minus 4 into 2 into 6, so that is equal to 1 minus 48, so which is equal to minus 47. Delta is less than 0. Whenever delta is less than 0, roots are imaginary. Conjugate complex number. That implies that delta is less than 0. The roots are imaginary. The roots are imaginary and complex conjugate each other. And complex conjugate to each other. Complex conjugate to each other. So this is the way the nature of the roots we will decide. I hope everyone understand that. In the next video about the problems which are related to the common root and transformed equations, like if the roots are minus alpha minus beta, then the equation is minus f of minus x equal to 0. If the roots are reciprocals 1 by alpha 1 by beta, f of 1 by x is equal to 0, required equation, quadratic equation, or transformed quadratic equation. If the roots are k times of alpha, k times of beta, the required quadratic equation is f of x by k equal to 0. These are the models we will discuss in the next video, like some synopsis I will give, and different models also I will discuss in the next quadratic equation video. Thank you dear students for watching my channel. Thank you all.